Okay, we have here another interesting integral from the Columbia Integration Bee 2022. This one here was problem 20. We have the integral of dx over the square root of tan x. Okay, this one was quite a bit of work and I had to be careful working it out. So I'm going to start with the u substitution. I'm just going to call my u this whole denominator. So I'm going to say u is equal to tan x. Of course then u squared is going to be tan x. And then I can get a value for x. We can write x as arctan of u squared. Then from here, I'll just go ahead and take a derivative. So we're going to find our dx value. Derivative of arctan, this is going to give me 1 over u to the fourth plus 1. Then I'm going to need the chain rule. Taking the derivative of u squared is going to give me 2u du. So we'll go ahead and we'll make the substitution. So what's going to happen, for my dx, we're going to have this thing. So I'm going to write this as 2u du over u to the fourth plus 1. But then our square root of tan x is just going to be u. So we're going to have a u right here. But that's okay because our u's are going to cancel. I can take a 2 out front of the integral. Now for the integral of 1 over u to the fourth plus 1, I feel like I've done a video on this integral before, and I'm not sure, there's probably multiple ways to do it. The way I like to do this, what I'll do is I'll multiply numerator and denominator by 1 over u squared. And then let's just see what we have when we multiply this in here and here. So again, we have our 2 up front. I'm going to end up with 1 over u squared du in the numerator. Then multiplying this in, this is going to give me u squared plus 1 over u squared. And I always like it when we get this kind of setup here with the 1 over u squared situation. This is always interesting to me. So the fun thing with this is we can actually factor this 2 ways. So let's take a look at this. What I can do is I can take it and just write it as u plus 1 over u. I can square that. Now when I square that and multiply it out, notice you get u squared plus 1 over u squared. We get an extra 2, plus 2. So then I'm not changing this, I'll just subtract 2. Then my other factorization for this is going to be really similar, but u minus 1 over u. So then when we square this, again we get u squared plus 1 over u squared, but now we have a minus 2. We don't want to change it, so we're just going to add a 2. So now I have a way to write my denominator 2 different ways. What I want to do is split this into 2 integrals and try to do another substitution. And what I'm going to do, I'm going to kind of try to set up this whole substitution in advance. So one of our substitutions is going to be for this thing, like I'll call this t. And then the other substitution is going to be for this part, I'll call it w. So then before we do anything, let's just look at what our dt value is going to be. Taking the derivative of this is going to be 1 minus 1 over u squared. Then looking at our w value that we set, if I take a derivative here, our dw value is going to be 1 plus 1 over u squared du. So now that we have all this information here, what I'm going to do is I'm actually going to set this up. Basically what I'm going to do is I'm going to set up 2 integrals. I'm going to set it up exactly the way I want it and then kind of just make it work after the fact. Because of course we can't change it. So when we put together these 2 integrals, we still need to have this be our numerator. Okay, so now we have this broken up into 2 integrals. Now you'll notice here, I've written the denominator 2 different ways. I've used this first, this t way. We have that one here. And then the second way, our w, we have this for our second denominator. So these are the same values. This is the same as this. But now what I've done is, knowing that I'm going to do like a t substitution here, and this is our dt, I set up my numerator exactly the way I wanted it, that way. And then here I'm going to do a w substitution. Again, I set up the numerator exactly how I wanted it. But now the thing we need to check is, did we actually change this thing? So again, with the denominators the same, when we add these together, the plus 1 u squared, the minus 1 u squared is going to cancel. So when we add these together, we're going to end up with 2 in the numerator, but that's not the same thing as 1 over u squared, of course. Now, what I think I can do to fix this, what if I just multiply a minus here? So by doing it this way, when we add up all of our numerators, now the 1's are going to cancel when you distribute in the minus sign. But then when you distribute in the minus here, we're going to end up with 2 copies, 2 over u squared. That's actually the same thing we have here when you distribute in the 2. So now at this point, I haven't changed the problem. I can go ahead and we can do this substitution. So let's see what we're going to have. I'm going to try to squeeze it in over here for now. So just going back to our table here, we've said this value is going to be our dt value. And then in the denominator, this is going to be just t squared minus 2. And then here for the second one, we've said this value is going to be dw. And our numerator is going to be w squared plus 2. Okay, with the rewrite, I just reordered these and put the w integral first and the t integral second, just to have the minus sign there. But now we actually just have two easy integrals. One thing I'm going to do with the 2, I can actually write this, instead of writing it as 2, I can write this as square root of 2 squared, and I'll do the same thing over here. And then for each of these integrals, we're just going to use a formula on these. Okay, over here to the right, we've got two really similar formulas for these two really similar integrals, right? But the only difference here really is the minus sign. And so we notice, this is probably the more familiar one, right? We've got our arctan formula here, but then we have dx over x squared minus a squared. We just use the hyperbolic tangent instead of the regular tangent. And also keep in mind we have this minus sign out front. So I'm going to go ahead and apply this, and just keep in mind our a value in each of these is going to be just square root of 2. So for this first one, using the blue formula, this is going to be 1 over square root of 2 arctan of our variable, which is w over square root of 2. And then for the second one, the minus in front here is going to cancel with this minus sign. So I'm going to end up with plus 1 over square root of 2 hyperbolic inverse of t over square root of 2. Now, before I back substitute, I'm going to try to do some simplification first. So like what I can do with the t and the w values, get a common denominator. So I can actually write this as u squared plus 1 over u. And I can write this one as u squared minus 1 over u. And then maybe to save a step, what I can do is back substitute here in one step so I can get our u value, because our u squared value is just tan of x. So we can write our t value as tan x plus 1 over u is just going to be square root of tan x. And then really similar for our w value, this is going to be tan x minus 1 over square root of tan x. So let's see if I can put this all together. So we're going to have here 1 over square root of 2 arctan. Now I'm going to pull this square root of 2 into the denominator here for the w values. This is going to end up being tan x minus 1 over square root of 2 tan x. Same kind of thing over here. We're going to have our hyperbolic inverse. And then for our t value, we get this tan x plus 1 over square root, again bringing in our 2 tan x. And we'll just put a plus c on it, and that's it. Okay, good problem today from the Columbia Integration Bee. We'll stop it there. Thanks everyone for watching. Have a great day.